All right, welcome back, everybody. Hopefully you guys, some of you attended the video or the thing on Monday. Hopefully you watched it. We went over vectors and arrays and shit like that. We looked at templates for a second. We're going to do a lot more with templates today. But we didn't cover classes yet, and so I want to hit on classes. And so we're going to incorporate classes in with our templates and a little bit of inheritance for today. So, we have a class, we got point here. You don't want to capitalize point, you want to capitalize classes, data types, stuff like that. We use lowercase variable names to start, they start with lowercase for variables, but for a class we're going to capitalize it. We do have a private section and a public section. Private is only accessible by an object that instantiates this class. I could have put the Y here and not put it there. But for where I'm going with this lecture today, we're going to do it separate. You do need a constructor call. So you're going to tell it what goes in it and what the initial values are. You do not need to actually have a variable name there. We could just as easily say int equals 0, int equals 0, comment out this other one, and it's the same thing. So that's optional. I think it's helpful to actually leave that one in. I know Mr. Redden likes to teach it where you don't put it in there, but I think someone, if they're looking at your class because they're going to use it, as we're going to do today, it's called inheritance. Knowing which thing goes in which slot is pretty handy. Like I don't want Y in the first slot, I want it in the second slot. We're going to look at virtual more in a little bit. And then we've got it as a prototype. We're above the main here. You guys are going to want to do everything as prototypes. This is a prototype method. And we will do the implementation of the method down below, down here. So we do it for both of them. As a reminder, you always got to do this double colon. That's the scope resolution operator. And you start off with saying the name of the class and then double colon, and then the things that you've labeled as methods in the prototype up above. That includes your constructor method, the point right here, and a print method that we have right here. Hopefully you guys remember that. Feel free to type along and play along at as you'd like. And we can just implement a point here, my point. And we can just start off, it's got to be an integer. And when we want to print them, you do my point and then hit period, and any methods you've made pop up. So I typed in the name of my object, my point, and you hit the dot, it gives you a list of the methods you created that are usable in the main. The only method that we have that is usable is the print method. So I'll do it, and it was a void, do that, and we hit run. What? Looks like it ran to me. Lame. I definitely like having a couple end lines in there. Make sure you're including the IO stream for when you use it, like if you're outputting stuff. Using namespace STD is really a much easier way to go. Some people in CSCI 2 were not doing this, I think because they were copying shit, because a lot of shit on Geeks for Geeks and stuff like that doesn't do it. And then every time you do something that's in the standard library, you have to do std : : like cout is in the standard library. If you don't have using my namespace, you have to do that every single time, and it's tedious. So using namespace std, way to go. In fact, for things you're doing, You might put your name on it. And wait, why am I using a hashtag? That's not gonna work. There we go. Dave Jones. El Jefe. This is lecture A. Since we're gonna do inheritance, I'm going to open up another one in a second. Day 2. CSCI to fall 2023. All right, so what else can we do with this? If I wanted to make this double, like if I want my point to hold doubles, what happens if I try to put in a double? What goes on? What's going to happen here for 3.3 and 5.7? Remember what happens if you try to put in a double for an int?
Rounds down.
Rounds down, right? 3, 5 still, even though one of them was 5, 7. So if I want to make this double, I have to go through and make that a double. I got to make that a double. I got to change that to a double. I got to change that to a double. I got to come down here and change these to doubles. And then I'm okay. That's a pain in the ass. So what we're going to do is we're going to use templates. So we're going to say template, and previously we did type name. In fact, I'll do type name real quick here and comment it out. Type name T. This was the command that we would use for functions. The one that we use for classes is template class T. Nothing goes after the last arrowhead because these are technically one line, but they're harder to read that way. So I keep them separated. And T is now our new data type. And so I want int to be a T everywhere. And we want, since it's a data type, we want it to be capital T. If we need another one, it's usually useful to do T1 and T2. We're going to explore using more in just a second. So I'm changing everywhere it says int except in int main void to a T. I'm going to come down here and change this to a T and this to a T. And notice it's giving me a problem. And it's also got a problem here. When we do it, unfortunately, we have to put the template class T in front of each of them. So I'm going to be lazy and copy and paste and put it down here. And we need to treat it like a vector. So, wait, not right there, down below though. Point T. There we go. I do need it there. Oh, what? What am I doing wrong here? Oh, actually, I don't put T, I actually tell it what I want. So if I want this to be an int, I do an int. If I want this to be a double, I do a double. In fact, we'll do the one with the double. And then we'll come down here and we'll do one. Let's just see how the double works. What's off here? Save. Should auto save. Y identifier not found, line 35. Oh, I see it. There we go. So we can do that, and I can make a new one. Everything's got to have the same type right there, and it's got to be capitalized. It's got to match what we have up here. I'm going to get rid of that one right there, and I don't care for it. We can do, I can make another point. Maybe I'll do it after this one. Point. We're not restricted to numbers. We could do a string. My string. David Jones. The only thing I gotta do is if I put string here, I gotta include the string library. So now I'll throw that in there and bust it out. Oh, I didn't see out string, or my string. So we'll copy this down here. And I gotta change this to my string. So let me pause for a second, let you guys absorb that. So what goes down below, we needed to say template, class T before each one. You also need it to say, treat it like it's a vector thing. In the implementation, you're putting the T's, but when you use it in the main, you're replacing T with the data type you want to use. Now, right now our class is a little bit light. We don't have any get and set methods, and we kind of want that. I want other people to be able to use this, so I'm going to set up some get and set methods. Let's see, what do we want to do? So create accessor methods. Let's do get first. And if we're getting it, it should be returning a T. T get first, void. And then we'll do void set first. And that will take in type T. That'll cover our first one. I could say get X and set X, but I associate X and Y with like a coordinate, and if we're gonna have stuff like strings in there, maybe I wanna make it clear it's doing the first one and the second one. Then we'll do one for like get second. And void set second. This is camel case. It's been a while. I've been, at least you dabbled with programming over the summer. So I'm going to copy these down below and implement them. And unfortunately, in front of each one, we need to put that template T, or template class T. So I'm going to do that first. And we also need to, for each one, put in that point arrow T with the scope resolution operator. So don't forget to do that. I'm going to do copy and paste for it because I don't like taking forever to type a command. I don't think you guys do either. So I got the basics set up, I just gotta go through and set them up what they do. So this will, it's getting first, so this should return X. And set first should take in the argument. So I gotta give it a name, TR first. And we'll say X equals arg first. So if you've forgotten getting set methods, this is the way you do it. Come down here and do the same for these. This one we're returning Y. And here we're setting Y. Let's put in arg Y or arg second. And Y equals arg2. Now, if we want to, let's just make sure everything's running still. I haven't actually done anything with them. Let's just make sure nothing's bugging, that those things are set up. Everything still ran. So I'm going to go through and I'm going to change my constructor call to include those. I'm just going to say get first. And I need to, nope, I'm setting it. X, set first. A. And then for setting Y, I gotta do set second. And that'll be B, the way I've got it written. Now this should still work. My set methods should be placing A into X and B into Y. And good, everything's running smoothly. Any questions? None? There are no questions. Yeah.
Do this in the notes or are in the canvas as well?
There's a variant of it in Canvas. I'm doing a different thing right now, but yeah.
For how you organize, I know it doesn't really matter exactly to the code, but you always organize in the specific order when you're doing your implementation?
No. Sometimes, like, I usually put all my get methods together, to be honest, and my set methods together. That's a great question. So just make a note of that. You can do all the gets first, or in either order, all the gets together and sets together.
I meant overall, like the constructor, then the get sets methods, and then finally your.
I do.
I
don't know that you need to. I think the constructor can go below. Normally I put my actual utility methods down here. Crap. So this is a utility method. It serves a purpose. These are called the accessor methods. And you should have a get and a set for each of the variables that you have. So virtual here. We will use the virtual in inheritance, which we're going to do in a little bit. Here it doesn't do anything. Doesn't do much. What it does overall is it says any objects or classes that inherit off of this class can use this method without making their own. Making its own. So they'll automatically, like if I make a new method or a new class that is maybe a 3-dimensional point, oh, that's not a bad idea. Let's do that. Let's take a look at inheritance to 3-dimensional points. So I got a point here. What should I call my 3-dimensional point?
Are we still synthesizing?
There's more I wanted to do with templates, you're right, maybe I should hold up on this. Right now, this is forcing the two things to be the same, X and Y have to be the same. So, if we don't want X and Y to be the same thing, like say you want like a name in the first slot and a char in the second. We need to have two different things here. So the way we can go about doing that is we can do, if we want to make it two different variables or data types, we can do class T1 and class T2. And then we got to go through and actually label these individually. So the constructor changes, the names of the data types change. Some people use T and U and B. T1, T2 is just as good. Get first is referencing X, which is T1, so I need a T1 there. And set first will set first to T1. Ooh. T2 will be like that. Set T2. And then we got to go down and change all the shit down below. So class T1, class T2. T1, T2, T1, T2. So this gets to be a pain. But I'm going to go through and change all those real quick. And I'm going to do the T1, T2. Got to change that on each T. That's returning T1. That's setting T1. That's returning T2. And that's setting T2. So this is a way of setting that so you can use different types. Leave that up there for a second. It looks like processing, some are typing. What has to change here is you have to now in the main do both like that.
So it's in the main where you specify what T1, T2 are.
Yes. And let's say I want to change this, I want to make this a char. I have too many. There we go. So when we do it, now I have it saying David A. You don't have to change them. you can leave them as a double, but since we updated everything up here, we kind of need to show it twice down here. Which is kind of cool. We can make a vector of points. And then another arrow for that. So the outer arrow is for the vector, the inner arrow is for the point. I'll call it my vec. Oh, I need to include vector. So now I've got a vector. That's too many spaces, it makes it hard to read. There we go. And we can just start pushing back some shit. My bad, push back. Oop. David, and here I said int, so number 1. Why is pushback not working? Point. There it goes. So unfortunately, when you do a vector with something like this, you do need to say, like I tried to push back a point, but it wants this point string in every single time. So I want to add another person here. I need to say this each time. One is number 2. And getting it to print out, maybe we do a quick loop. Or int I equals 0, I less than my vec dot size, I plus plus. We've got a print command, so we just need to access it. So my vec I dot print. I can choose to change the information afterwards. Let's just run that and show it real quick. So I've got David 1, Juan 2. Looks kind of crappy that way, doesn't it? Maybe we should throw in a C out so that they're after each other. There we go, David 1, Juan 2. And, okay, what if I want to change it? I can always go in and edit information. My vec, bracket 1. I don't like that it's a David. I want it capitalized. So I can do set first. And capitalize it. And we'll do that with 1 on 2. And then I will reprint. So I'm going through, I'm updating the names, I want capitals. Ooh, I pissed it off. What did I do?
You know, you do the point string int in front of the MyVex.
It shouldn't.
Wouldn't it be 0 and 1 for the vector?
Good catch. What's your name?
Jose.
Jose, all right. Jose just got added to the vector. Jose is my number 3 now. And I gotta tell it string, oops, spell string correctly in. And so when you're doing it, it's like you're initializing the point all on its own. I do without giving it a name, and when you're pushing it back, that should work. Let's try that. There we go. Much better. You're right. I really hate that it starts at 0. That is never like that is when we learned how to count, and whenever we learned how to count, every person on this goddamn planet learned how to count starting with 1. And then they do this shit and they start with 0. I'm like, go fuck yourself. What else do we want to do here? Oh, let's say I'm gonna make this, I'm gonna change this to char. And change each of these to a char. And that means I gotta change these. Oh wow, that was neat. Fuck yeah. What the hell? Nope.
Oh, you have to highlight.
Oh, I highlighted it, I just hit the colon and it made the char out of it.
Yeah.
That's fucking sick. I like that. That's handy. Okay, so I wanted to point out something else. You don't need to templatize everything. If I were making this like a student, putting those as chars, you know what, we're gonna go with like grades. Everyone got an A on the list so far. This is like making a student, we're gonna say. And like maybe I want another variable in here. Like our age. This does need to take in the, age is never gonna be a different data type, right? It's always gonna be an integer. So we can leave that set in there like that. And we can do a prototype of our age is 0. And it's not going to change what we do with these, with the T1 and T2 down below. This can still stay like this because the int is not part of the templatizing. So, we just need to include an age. It needs to have 3, so we'll say that's 21. These are all 21. David's not 21, David's 48. David's 48. Want to say how old you are?
What?
Do you want to say how old you are, Jose?
17.
Baby.
Two?
But you get some young whippersnappers up in this motherfucker. I've had like a senior in high school taking Calc 3.
What?
Yeah, and what was really impressive was he re-derived spherical coordinates on the fucking exam. It's not an easy thing to do. It's not, you're drawing a sphere, you're deriving, it's not easy. Jacob's seen the spherical coordinates. He couldn't remember what they were, so he fucking just re-derived them on the fucking test. I'm like, God damn, this guy. We do gotta go down here and change some of this shit. I need an int down here. So int our age. And maybe I need to make some more accessors. So we'll do set age here. Set age is arg age, and I'm gonna have to go through and make some of those. So I'm gonna come up here and make them. Int get age, void, and void. Oh, that's not spelled right. I got 2 capitals. That was bad. And I'm gonna do get age and set age. And I gotta come down here and make them down below. It's already getting mad at me. Let's see. That, I can copy that whole thing right there for void and get that one set up. And if I do that here for int, I'm gonna have to change something. I gotta change that to an int. And now it needs to actually return it. Return age. And this one is age equals arg age. We can have a little bit of data validation here. This is probably good. If arg age is less than 0, maybe we make arg age equal to negative arg age. So by doing our data validation in our set methods, this constructor is free to do whatever it wants. And the only other one that needs to change is, I changed that. We should probably change out this, right? We should add more to it. So let's add comma and say age equals age. Okay. Presumably I fixed everything. I got ages in there everywhere. Let's give it a gander. There we go. So now we can have an age in there. And the age is, since it's always an integer, we just left it as an integer. And we didn't need, so you don't templatize shit you don't have to. Because you saw how much extra work it does to templatize. Only templatize the things that might be changing. Let's see, what else do we want to do? We haven't talked about pointers with this. So I'm gonna make a point. String, we'll go char again. It's gonna be a pointer. And we'll call it person, my person. Am I missing anything here? No. And then when if you're gonna do that, we have not set up anything for my person. So when I define it, I need to make it, I'm gonna use a new command with you guys. Back, the command is new. We're gonna do a new point, string char. And who else wants to be immortalized in today's lecture? Any volunteers? Kenny just got volunteered. Kenny gets a Z for Zoom, and it needs to be like that. I don't know how old Kenny is. We're gonna say he's 18. And ta-da! Okay, so I made a pointer with our point. Maybe I shouldn't have called this class point if I was gonna use pointers later. I have to think about that next time I teach this topic. We made a pointer out of it. I called it my person since I'm using a name and I'm giving them a grade or a letter. We got their age in there. How do I print it out though? If I try to do my person.print, ooh, you put the print in there. Will that work? Let's give it a try. I did not want to do arrows with you guys yet. But there it goes. Let's see. What I wanted to do was say we can, that's one way. You, my person, and as soon as I hit dot and picked one, like if I do that, say get set, it's gonna change it to an arrow. So it uses like pointers rather than dots for pointers. That's not what I want to go with. I was gonna go with saying, let's, God damn it. Sometimes that is handy where you like hit the key and it surrounds it with it. The other option is dereferencing it. So it should now do it twice. It's actually a good way to show it. So for pointers, you need to dereference to access the information. And we dereference using the asterisk in front of it. I don't know if this set of parentheses is needed, so why don't we try getting rid of it? And it is. Notice it's giving me issues. So very much wants that set of parentheses there. So I dereferenced it, then I can access the command like normal. Or instead of dereferencing it, I can use an arrow. So since I'm gonna copy and paste these in the announcements later, this is by dereferencing pointer. This uses, what the fuck is the name of that arrow? I'm just gonna call it arrow notation until I fucking look it up and remember the name. All right, so something you should do, and I didn't do it this first time, is every time you use new, you should also use a delete at the end. If you don't delete, this can lead to memory leaks. So, down here, I'm just gonna type delete my person. So new goes with delete. There's no noticeable impact here, but if you've got a large enough program running on and other people are working with it, you don't want memory being fucked up. It's allocating memory as it goes. So, let's see, what was one of the names of the people I created? The first person I created was me. And so I had, the first one I did, zoom out. And maybe fucking auto-tune a little bit. And point in the right way, there we go. And lower the brightness. It already says it's as low as possible. Okay. So the first point I made that had a person, I had point, string, char, and this one was my string. And we had David, A, and 48. So at compile time, what it did is it set aside a box for this information. We got our data set aside here. I gotta have room for my name. I gotta have room for my character and room for my age. And this box was called my string. Okay? No pointers were involved, we just printed as is. If I wanted to make a pointer to it, I could. This all happens at compile time. So that's the first one. Then we came down, and I want to make sure I spelled the way I did earlier. I said point string char pointer my person, and then I declared my person to be a new person. New, learn to spell. New, this was a point class. We still got to go through all the rigmarole. New string char, and it was, we did Kenny on this one. Kenny got the Z, because he's on Zoom. We said he's 18. Kenny says he's 24. We're changing that. Let's change Kenny. Kenny's now 24. And when I did this, it created a box for him that has all his information. But the box is not named. There's no name on it. All we have is the pointer, my person. So my string was the name of the object. And my person here is just a pointer to memory. This happens at runtime, when you're actually running the program. It doesn't mean a lot because I didn't have any user input, but like if I have user input and I just like how many people do you just keep storing names until you say 0? And so they can just keep typing away name, character, age, name, character, age, keep pushing back or making like putting people in a vector, keeps creating new people at runtime. And then like that ties up a lot of memory. And then even if this program is part of like a bigger program, like say this is in a database, and the database is ongoing, and this is only the add new member part to the program. If I leave that going, in addition to it storing there, if it's writing it somewhere and it stays there, we don't need to have this storing up extra memory for where we set it right here. So we want to delete it all out here. Delete it to kill it at the end. Okay. And Go back to laptop. Notice, like int and void and double and virtual are all blue. So is new and delete. New and delete are keywords. And so deleting, I didn't actually say what it does. Delete deallocates the memory. Any questions?
Why exactly do you need to use new if you already declared it as a point?
Because I just said it was a pointer, nothing was actually identified here.
So if it wasn't a pointer, then you wouldn't have to do the new.
Right,
Okay, that makes more sense.
yeah, the new is definitely going with the pointer part. You don't need new for the rest of it. Good, great question.
Pointers point at addresses, they don't point at, well, they
Yeah.
do point at objects, but they're specifically.
Pointer gives it's pointing to an address in memory. And that's all it is. So that's what we had on our picture up here. It's just pointing at the location. Until there's, before I did the new, it was just pointing at the location and there was nothing there. There wasn't even boxes there. Until we said, hello, Kenny, welcome to being the object at the end of this pointer. Any questions so far? Or any more questions, I should say? Not everything needs to be in a class. Let's make a new, let's do like a maximize, or find a maximum. So let's say we're gonna make a new function and we are going to compare two integers.
You were mentioning right now that certain words are blue, like darker shade blue, maybe, what were you saying before?
They're either data types or keywords. They're words the computer already knows. So don't use new or delete as like variable names and shit like that. Just like you can't use int as a variable name. It's actually commands that are embedded. So I'm gonna make a maximum function that returns the maximum of 2 arguments. And so why don't I be smart and just copy it down there? Come down to our implementations. I'll do it before the class implementation. So like if arg1 is greater than arg2, I should return arg1. Otherwise, return arg2. Is that okay for a second? All right, let's go up here and use it in the main real quick. See out. Oh, this is probably easier if I just give them letters real quick or values real quick. X1 equals 7. I like number 7. X2 equals 13. Then we will see out maximum of X1 and X2. Maybe there's some end lines in there. I hate when it has all that wall of text that underneath it and hard to see. So I return the 13 and make sure it works. Let's just change the order. Maybe we'll get rid of one of these end lines. Don't need a lot. It's returning 13 both times. All right, so now I'm gonna go through and look at it and go, what should I templatize? Working on just doing more stuff with templates. We're gonna make a template with this. This is not a class, so we need to use type name, not class. I'll go with T here. And these are all T's. Ooh, capitalize that bad boy. And we'll bring that down below. That was the prototype, gotta change the implementation. These taken T's. And so this is doing templatizing a function. We don't need different ones. They should both be templatized because we want to compare things that are alike. Doesn't make sense to compare things that are not alike. That's kind of fucked up. But we've already shown those two. Let's just make sure it still works with the integers real quick. And it does. And now we could also, I could say C out, or not C out, char y1 equals little a, char y2 equals big A. Who remembers on the ASCII key table which numbers come first? The lowercase or the uppercase?
Lowercase at 97?
That sounds about right.
I think so.
97 or 96, I don't remember. We're gonna find out. So I'm gonna copy this and I'm just gonna make sure I change it to Y. Beautiful little program. I love templatizing stuff because I don't have to make a new maximum function for character comparisons. So give me lowercase a, so A is the big numbers. Lowercase is the big numbers and the uppercase is the small numbers. That was a good check. So lowercase was the higher value. No one's expecting to memorize the ASCII with here. Oh God, that's fucked. I mean, you could memorize little a and big A and get everything else you need out of it for the characters, but it ain't all that. What if we do a string? Oh, string, we'll call Z1 and Z2. Z1 is David. Nope, we're gonna use names that are similar in length and even start with the same character. It's been an hour, I can tell because my Flex program came back on. I'm gonna disable it for another hour. There we go. And we're gonna take a look at this stuff right here. And change this to Z1 and Z2. I took this class with Redden a while back. He doesn't ever fucking copy and paste shit. He likes to go as slow as fucking possible. I think he's that employee that doesn't like his job and so he's dragging out the clock. You know what I mean? Like when you first started working like a fast food job, has anyone not worked a fast food job?
Is anyone not?
Not. Okay, let's try this. There's a lot of makes sense. Who has had a fast food job? When you first started, did you have to go to the bathroom more than you normally do? Just to burn out the clock a little bit? That's Redden in class, he burns out the clock. I suspect all of you use copy and paste, if you're not, you're just deliberately asking to spend longer on your programming. Let's see what do you guys think is gonna happen when I check to see which one's bigger, Juan or Jose?
One.
Think Juan will be bigger? Why?
Goes to the next letter, I think.
Think it goes to the next letter? That seems like a reasonable guess to me. The J's are the same. It might go to the next letter, U. U versus O. U's probably gotta be later on the ASCII key list. That seems reasonable. Let's find out if Juan's right. Yes. What happens,
Capitalize the J.
let's just make sure that works. Let's go with Jane for one of them. So here it should return Jane by that logic.
No,
No, it's still return. Yeah, you're right. I'm gonna put Jose. Undo. Let's see. How do I want to do it? I want to change Juan out. So let's get rid of Juan. Bye, Juan.
Oh.
Your services are no longer needed. All right, Jose's getting it. What happens if I use different like names? Is it really the character name? Right now, Jose was getting it. So Jose should still have it if it's based on the first character. Let's check it out. Yep. All right. So it's going by character, and we're just checking the next characters.
Or if you just have the letter J, it would just be.
Or was it? Each time. No, this one I deliberately chose Jose, but earlier when we had Juan, it was picking. Okay, yeah. This is tracking. Does that make sense? Everyone good? Check this out. So I've been saying what those strings are gonna be. What happens if I just type in Juan and Jose? So that's how I do it right there. There we go. Because these are different things. One is a declared variable. These were declared variables. And these are string literals. See the difference? They didn't all spit out Juan. Let me move this so you can look at the code. See how max Z1, Z2, Z2, Z1 gave us Juan both times because those were declared variables. When you put in string literals without like having a variable, it treats it differently. Jose got picked first. Let's play around with that. What's going on? Is it the last letter? Is it going off last letter now? Wanna, maybe? Let's go Wanna. Change. See if that makes, or was it just because it's longer?
I'm thinking it's the culmination of all the ASCII.
Maybe.
So if we were to like maybe,
Let's change it so it's got the same length. So I'll go Davy rather than Jose. Now Davy gets it, which is weird, so it's not last letter. Because yeah, E is larger than A, yeah, it would still be, it'd be last letter there. Maybe we'll change this to 1L, let's see if it is last letter. No, so it's not last letter. Maybe it's the cumulative value of it. So, like, what the fuck? Like, really, there's like, it doesn't, it's kind of hard to tell what's going on here. So like, keep that in mind when you're, like, that's something to keep in mind. Maybe use variables to guarantee that it works. Now, if you were using this in a program and like you're working with others, you probably would have variables, and there's no reason to like have it randomly insert it, but it's worth pointing out. All right, any questions on that one? Let's go take a look at inheritance. Let me copy and paste this in an announcement real quick. So lecture day 2, part A. I really gotta see what's the difference. I do not like the way that prints out. Before I do the other one, I'm gonna look. Let's close that one out and I have one on inheritance started up. Let's see. Lecture B. So I stole part of the starting stuff for inheritance. I'll show you where I got it. I'm pulling directly from inheritance primer. And I copied everything on the first one, but I deleted everything related to circle. So I just have the shape class and the shape implementations. So I've got my shape class, I've got a string as the only variable. So the color of the shape is all that we're gonna define here because we don't really know if it's got edges. It could be a fucking circle, it could be a sphere, we don't know. So we don't wanna say edges or sides or points or anything like that. We don't know what's going on. The color works. As a reminder, this is a global constant. This is a good way to do global constants. That way, pi value never changes in any program. And let's see what we got in our class shape here. Oh good, it kept it at 150%. So we got our string colors are private. We've got a constructor setting it transparent. Does anyone know the difference between transparent and translucent? Here's your fucking Jeopardy quiz question for the day.
Translucent, but wasn't it dark? Transparent should see through.
No.
What?
Transparent is see-through. That part's correct. Translucent doesn't have anything to do with glowing in the dark though.
Isn't it
like light can pass through.
Isn't it more reflective?
It's how light passes through it. Transparent, it passes straight through. Translucent, water's translucent. It can refract the light at a different angle. I looked this up because I was like, why transparent? That's your fun fact for today. So it looks like we've got a couple accessor methods already made. For void, set color, string get color. We've got two virtual methods here. These are methods that can be used later on. So virtual methods, I don't like the way this is worded here. Virtual methods can be implemented in, they're called derived classes. If it's set equal to 0, like calculate perimeter here is set equal to 0, it must be implemented in a derived class. Okay? So this one can be, like display info can be overridden, calculate perimeter equals 0. They both can be overridden. This one, you must do it in a base, in an abstract or a derived class. In any class that uses this one. All right, so we've got a couple methods here. Check it out. Let's try to make a shape. Can I make a shape? Since it's set up as an abstract base class, shapes cannot be implemented. I've got virtual methods here. Virtual is or this equals 0 is what's making it an abstract base class. Pretty sure that's what's happening. If we remove the equals 0, why does it not like that parentheses? That should be fine. It's not going to see out anything. What's wrong with it? Constant char 5 to shape. Interesting, it's still giving trouble. Doesn't like it. So I'm gonna get rid of that shape X and let's make a class that's based on this shape. In the lecture notes, there's circle. Nah, let's do something else. Let's make a rectangle. So when you make a class inherit from another class, you just use a single colon and you say public and the name of the class you're inheriting from. They're both going to have private still. And we got public. And let's see, what do I want to do here? What do rectangles have? The rectangle's got a length. So let's go double on the length. And they have a width too, right? Double width. Which means we're gonna need accessor methods for that. We're also gonna need a constructor class. We'll just set everything to 0 in the constructor, but we're gonna have to implement it down below. So there's my constructor. We're gonna need a get length, so double get length 40. Double get width void. And return. So I like having another space in there. Not return, void. Set length. That's gonna take in a double. argl. And you don't need to put argl there, but I like having it where it's more verbose. So anyone reading it knows what's supposed to go in each one. I think set length and set width kind of give it away, but you never know. And I'm gonna need this method right here. And I don't need to call it a virtual anymore. I need that one. And why not? Let's get this one down here too. Okay, so I got a bunch of methods listed. That's not supposed to be that should be a comma. And now I need to go down and implement these down all below. So we got our shape ones here. I'm gonna implement it after the shape ones. So rectangle, remember we gotta scope it. Ooh, it's doing override. There we go, fixed override. Rectangle, scope resolution operator, rectangle again. And all of these are gonna need that. Does that one need it? That one looks funny. No, because that's not part of rectangle. Let's see. Circle when it grabs shape. Yeah, it did do it. Okay, it should be doing it. One overload. Do I need virtual listed up here? I might. Nope. I don't. Well, maybe let's just go through and start implementing them and see what that, maybe that's what it's pissed off about. Rather than doing those, I'm gonna do the set arguments first. So length, is that how I spelled it? I think I use lowercase, equals RL. And width equals RW. What the fuck? I don't know that I like this automatically putting in shit. It did it on everything. There we go. And so now I can come up here and here we'll just say set length RL, set width RW. Maybe we should do some data validation here. If arg length is less than 0, arg length equals -1 times arg length. Can I just do negative arg length? We'll find out. And we'll come come down here as well. If RW is less than 0, do RW equals negative RW. I know that negative 1 times it should work. And since I've made them a double, maybe I'll make that 0.0, just to force it. Just in case it gets moody. Still gotta do these. This is return length. And this is return width. U. Okay. So I got a bunch of stuff for rectangle set up. I still need to calculate perimeter. So maybe I'm gonna say double len equals get length. Double width equals get width. And we can say return, I can do 2 times L, or len, plus 2 times width. And now calculated perimeter is not getting moody. So that was what was missing. We gotta do something with rectangle. What do we want to display with rectangle?
The area.
We want to do the area, so maybe we need to make another function for area. That's a good idea. Let's hold off on the display. Let's make one for area. So we'll say calculate area. And return length times width. And it doesn't like it because it's not implement, or there's no prototype up here. Let me go put it up here real quick. Doesn't need the scoping up there. And now everything is good. Okay, so we got a perimeter, we got an area, it's got a color. So see out. You see out rectangle info. And line, see out. Color equals the color. Oop, not equal sign. Equal sign would go there. There we go. See how perimeter. Calculate perimeter. And see out area. Looking good? We got one problem right now. Where is our little rectangle things? Let's go back to our constructor. Right now, rectangle is building off a shape, and shape needed a color. We actually need to take in the string here for argc. And we'll do set color argc. Now I gotta go up here and add this up to the implementation, to the prototype up top. So it actually needs the variables for the base class. Now, a rectangle doesn't have color in it, but it is inheriting everything that shape has. So it's going to go up to shape and it's gonna go, okay, I automatically get a color variable for free. I automatically get a set and get accessor methods for those colors. I don't need to remake them for this shape. I have to do this calculate perimeter, and I can choose to do display info. I think having a display info is pretty good to go, so this had nothing. These all overrode it down here. So display info and calculate perimeter overrode shape stuff. I saw red up here. What is wrong here? Double string. Double string.
Does that equal to anything? User has a instantiate.
That's it?
Yeah, it's really weird. If you do it for one of them, it requires it for the rest.
Yeah. And you should do it. And I don't see any red down here. Let's give this a try again. I'm gonna try doing shape again. I think I had the X or the equal part was what was throwing it off. Let's just say shape equals blue. Still doesn't like it. So that's not happy about that. So, we're gonna make a rectangle. Anything else that we need? We did a set length, we did data validation. All right, let's just build one, rectangle. It's not templatized, so I just call it my rectangle. I can set values to it right away if I'd like. It does take in 2 doubles and a string. So, double, 5.4, I don't know, 12.2 or 3, and blue. I clearly like blue. What's wrong with int main void? I'm missing.
Your class needs a semicolon.
Oh, that was a scrub move. See how easy that was to overlook? You gotta go. I love that it tells you where there's something wrong. Like the red squiggles, this is pretty handy. Go find it. Your something's wrong. It's just not gonna run. I mean, you can try it, but it's not gonna run. And then, like, if we want to print it out, we have a display. It was display, right? Oh, it's my rect. Let's just see what happens. This is what happens when you try to do too much before you run the first time. Let's go through and see what happened. Line 70, it's getting pissed off about. What happened on line 70? Oh, yeah. I'm trying to take in an argument, and then I'm trying to say that argument's 0, even though it already has a value. That might have been it. Copy and paste can hurt you. There we go. Boom. Oh, ugly. Ew, really ugly. We need some end lines in that display. All right, let's see what we got here. So this is inheritance. We were able to take stuff from shape and put it in ours. And what could we build off of a rectangle? We could build a box, we could build a pyramid, like a square base with a pyramid. This can be a class that goes on. So like maybe let's take a look at that. If I'm gonna make it go on though, I probably should make these things. Do I want any of these to go on? The display should go on. So I'm gonna make the display perpetuate onto the next one. I shouldn't need to do virtual calculate perimeter because shape already has it and it's gonna force us to do it. But we'll see. Let's make a box. Off a rectangle. All right, so we got box and rectangle. What does box have that rectangle doesn't? That's a height, right?
Yeah.
So we're gonna need a box constructor. And it takes in double arg L equals 0, double arg W equals 0. Those are commas, not colons. Double arg H equals 0. And we need a string in there. String arg C equals translucent, transparent. We need get set method for height. So we'll have double get height. Void. We will have set height. Double arg H. What kind of method should we have here?
Surface area.
Look at you going big. Calculate, I'm gonna just say calc surface area. Anything else? Lies, we need volume. All right, let's go down and make sure everyone, before I start jumping ahead, if anyone's typing along with me. So we got a get height, set height, calculate surface area, calculate volume. And we got our prototype for a box. We're gonna come down here below shape and set those bad boys up. Remember, we do need to do the scope resolution. On all of them. I'm gonna be smart and remember to get rid of these right now. So I'm not going WTF later on. And some of these we already have, so I'm gonna just go ahead and steal them from rectangle. And we need to do set height. Set height, we'll take in our gauge. All right, we gotta make methods for these. Set height, it needs data validation, so I'm gonna copy. Fuck it, I don't know that that's speeding it up. I gotta change so much shit that. I didn't test to see if it did negative, it didn't have a problem with the negative. R gauge equals negative R gauge. And then we're gonna height equals R gauge. There's our data validation there. On the get height, we're just gonna return height. Surface area, so I'm gonna do double, there's a lot going on here. We're gonna have length L equals get length. Double W equals get width. And double H equals get height. And we're gonna return. So there's length times width on two sides. So we've got 2 times length times width plus 2 times length times height plus 2 times width times height. I pulled that out of my ass. This one's pretty easy. Return get length times get width times get height. I think it's still gonna be pissed off at me. Oh, that's a capital H. Because I don't have a calculate perimeter. And I haven't made a new display info, so maybe I need a display info here. Let's have a rectangle display info. What do I want to have in here? Just go up and copy it. Change it to box. I think we're gonna need a perimeter, so I'm gonna say perimeter at bottom or base. Calc surface area, what's wrong with that? It is not. What's wrong here?
Isn't it because we're doing it from rectangle and not box?
Fucking scrub. Thank you. That was some serious scrub shit right there. Oh god. And oh damn, that's bad. And we'll throw in some volume.
No.
Maybe cubic units. And maybe we'll add some surface area shit right there. Square units. Now we're gonna need to calculate perimeter. I didn't make it, so let's make it right now. Double box. Calculate perimeter. Perimeter. Oh, I don't have it up top. And the bottom is length and width, right? So this should have the same perimeter as before. So maybe I don't need it. Perimeter is using length and width, and I am inheriting it. So maybe I don't need to put it in there. Let's come up here and instantiate a box. So let's put in some end lines here. I've got box, the box, 1.1, 2.2, 3.3, and red. And we will say the box, display. Look at that, it took the perimeter straight from the other one. So we didn't need to do it for box. Maybe I should put like units on perimeter. It's got everything going on, it inherits everything correctly. What else can we do in this one right here? Oh, check this out. Everyone okay with what we're doing so far? You guys are good with the inheritance? So the box took from rectangle and it didn't need hardly anything. All we added was shit for height. We added volume and surface area because we're overachievers. We didn't do any, we could have done calculate area. Maybe I could have cheated on the 2 times length times width that we had calculate area up here, which was off length times width. I could have probably just said do that twice, 2 times calculate area. There's also something else neat here, or I'm gonna go down to box and do it here. This is fucking long and clunky. There's like a lot of shit going on here. I'm gonna comment that out. So we got box. I definitely need to do. All right, it should still say all the same shit there. But watch this. I can say rectangle, arg L, arg W, arg H, or arg C. And now the only thing I should have to do is set height. By doing this with the rectangle afterwards, I don't need to redo everything in that thing. So this should still run, even though I've commented it out. What it's doing is it's taking arg L, arg W, arg C, passing it to the rectangles constructor. So the rectangles constructor is gonna do what its part, and then our constructor here for box is only gonna do the new shit. So it should still work. And we could go back and do that for rectangle. Rectangle doesn't need to do string argc. Check this out, we're going up to rectangle. I'm gonna copy that because I need it for a second. We're gonna comment that stuff out. And I can say shape argc. And now I only need the set length and so, and I'll run it, and I'll draw a little picture and then we'll be done. So what do we got going on here? We have shape doing color. And it holds color. This is an abstract base class. And then off of color, or off of shape, we built rectangle. And it added two more, it added length and width. This is called a derived class. Off of shape. So that was rectangle. Maybe I'll write it over here where it's not so small. And from rectangle, we had box. And all this had was height. And this is derived off of rectangle. So like rectangle is a base class for this one. But when we did the box, arg-L, arg-W, arg-C, there's an arg-H in there. And we passed arg-L, arg-W, arg-C in our constructor. What it did here is it said, okay, here I'm gonna set my height here, will be arg-H. At this level, it takes this and it passes it up to this one, to rectangle. Rectangles was also derived off of shape. Arg-L, arg-W, arg-C. It was derived off of shape, which just had arg-C. Here it's set L and W, and then it took shape up here, and it set color to arg-C. So it transferred the constructor information, it kind of like trickled down to what it needed. And so like this could get really big. You could have something that uses a lot of other shit. Like if we made a cylinder, we could probably build a circle first, have the circle build up to a cylinder. And now we've got a box and we've got cylinder. We could make a car. A box with 4 cylinders on the side is a car. So like, just like if you were like making something for like a video game, you start with the objects and you can just keep grabbing smaller shit and building off of it. So rather than trying to do an entire fucking car class, just do little shit. Maybe the cylinder, do the cylinder, and then do a new class called wheel off of cylinder. And you can just, that way, like if you want to add details to it, like, I don't know, treads or anything like that. I don't know. There's a lot of shit going on. It's 5 o'clock. I hope this was informative. Any questions?
Friday night next week?
What?
Friday night is next week?
I think it's September 8th is the first one. I know, it seems like they're waiting like a fucking month. And I think that's the night they're doing their like, come one, come all bullshit. Like they're opening up shit into the Ponderosa lecture hall to like do presentations and stuff. I don't know, I gotta ask Tess what's going on. I will see you guys later. I might have covered everything I needed to about inheritance and may not need to do one.